Gravity sensors across the globe just spiked as something impossible emerges from the frozen depths of the Oort Cloud. Subscribe now to track this light-consuming silhouette before it reaches us. A colossal, light-consuming silhouette is currently displacing ancient debris and steering directly toward the 3I Atlas trajectory. This isn't a natural comet. We are tracking a non-ballistic entity that is actively rewriting the laws of physics. Imagine sitting in a quiet room, and suddenly, every single glass of water starts to ripple at the exact same time. That's essentially what happened in February 2026, but on a planetary scale. We aren't talking about a tremor or an earthquake. We're talking about gravity itself, the very fabric that keeps your feet on the ground hiccuping. The data coming out of the NASA Jet Propulsion Laboratory, or JPL, was the first red flag. For decades, we've used high-precision sensors to track the hum of the universe. But what hit our screens a few weeks ago was a scream. Something massive, something we can't see with a normal telescope, just shoved its way into our backyard. And the weirdest part? It's headed straight for our newest deep space scout, the 3I Atlas probe. In this video, we're gonna peel back the layers of this cosmic mystery. We're looking at the actual sensor readings, the panicked emails between observatories, and the terrifying reality of a void that doesn't just sit there, it steers. By the time we're done, you'll see why the smartest people at Harvard and Stanford are losing sleep. This isn't just a rock in the dark, it's a game changer for the human race. Let's start with the Oort Cloud. Most people think of our solar system as the sun and the 8 planets, maybe a few asteroids here and there. But way out past Pluto, way past the Kuiper Belt, sits the Oort Cloud. It's like a giant, icy shell made of trillions of pieces of space junk left over from when the solar system was born. It's been quiet out there for billions of years. It's a graveyard, or at least it was. On February 14th, 2026, the Vera Rubin Observatory in Chile noticed something wrong. They were doing a routine sweep of the outer rim when their software flagged a gravitational flux. Basically, the gravity in a specific sector of the Oort Cloud spiked so hard it looked like a glitch in the system. But it wasn't a glitch. When the team at the European Southern Observatory looked closer, they realized thousands of icy bodies, comets, that have been sitting still since the dawn of time were suddenly being pushed out of the way. It's like watching a giant invisible ship plow through a field of icebergs. Whatever this thing is, it's big enough to move mountains of ice without even touching them. Now, normally, when something big moves in space, we see it. It reflects sunlight, or it glows with heat. But when the Keck Observatory in Hawaii turned its massive mirrors toward the disturbance, they found nothing. Just a hole. A localized patch of nothingness that was blocking out the stars behind it. No heat, no light, just a shadow that shouldn't be there. Dr. Sarah Martinez at the Harvard-Smithsonian Center for Astrophysics was one of the first to point out the math didn't add up. If this were a rogue planet or a dead star, it would follow a very specific path. Gravity is a law, right? You fall, you hit the ground. A comet orbits, it follows a curve. But this shadow, it's changing its mind. We started comparing the new data with the Arecibo legacy data, the stuff we gathered from the famous radio telescope before it collapsed. And we realized this isn't the first time we've seen weirdness in this sector. But at times is the first time something has started moving toward us with a purpose. The primary point of interest is the 3I Atlas probe. This is a high-tech scout we sent out to study the edge of the sun's influence. It's currently our furthest eye in the dark. And for some reason, this massive silhouette has adjusted its course to intercept it. It's not falling toward the sun. It's hunting a specific piece of human technology. Think about that for a second. In a universe so big it's impossible to wrap your head around, something just woke up in the frozen depths and decided to take a turn toward a tiny little probe we built in a lab in California. NASA engineers are scrambling. If this thing is non-ballistic, it means it has an engine, or at least a way to control its movement that we don't understand. It's breaking every rule of Keplerian physics, the stuff that says what goes up must come down and everything moves in a predictable circle. This thing is zigzagging through the debris of the Oort Cloud like it's driving on a highway. As we look deeper into the telemetry data from the 3i, Atlas, we're seeing the probe's own sensors reacting to the shadow. The gravity is so heavy, it's actually slowing time down by a fraction of a microsecond near the probe. That's some Einstein-level stuff right there. We call it time dilation, and you usually need a black hole to see it happen. But we're seeing it happen to a shadow in the Oort cloud. When you look at the flight path data coming off the 3i, Atlas, it honestly looks like a glitch at first. In space, everything is a mathematical certainty. You launch a ball into a vacuum, and it follows a curve dictated by the nearest sun or planet. That is Keplerian physics 101. But the shadow we're tracking across the Oort cloud is doing something that should be physically impossible for a natural object. It is performing what engineers at the Jet Propulsion Laboratory call active station keeping. This means it's not just falling through space, it's correcting its course. It's adjusting for the gravitational pull of the outer gas giants to maintain a dead-on intercept course with our probe. Imagine you're watching a rock roll down a hill, but halfway down, it suddenly swerves to avoid a tree and then speeds up to hit a moving target. That's what we're seeing. Standard long-period comets, the kind we've studied for centuries using the Hubble spectrograph records, have very predictable ballistic trajectories. They are slaves to gravity. This entity, however, is a rebel. It's moving in a non-ballistic pattern, which is a fancy way of saying it has a steering wheel. This isn't just a discovery of a new planet. It's the discovery of something that is actively pushing back against the laws of the universe as we understand them. What makes this even creepier is the total lack of a thermal signature. Space is cold, but everything has a temperature. Even a frozen rock at the edge of the solar system reflects a tiny bit of sunlight or leaks a microscopic amount of infrared heat. When the European Southern Observatory pointed their most sensitive heat-seeking tools at the 3i, Atlas coordinates, they found an absolute 0 point. It's a thermal dead zone. This object isn't just cold, it's a perfect absorber. It is drinking in every photon of light that hits it and reflecting nothing back. It's essentially the ultimate stealth coating, but on a scale the size of a small moon. Scientists at Stanford, working with the old Ronald Bracewell radio astronomy concepts, have suggested that such a profile isn't just rare, it's manufactured. To be that invisible while being that massive requires a surface material we haven't even dreamt of yet. We're talking about a material that can displace thousands of tons of Oort cloud ice while staying completely dark to our most advanced sensors. It's like a submarine moving through a crowded harbor without making a single ripple on the surface, yet every boat it passes gets tossed around by its wake. Deep space imaging from the James Webb Space Telescope has started to show us the void in higher resolution. Because it doesn't emit light, we can only see it by what it hides. It's currently obscuring a background star field in the constellation Cassiopeia. As the shadow moves, stars simply wink out of existence on one side and reappear on the other. But here's where it gets truly wild. The stars don't just disappear, they stretch. This is the gravitational lensing effect I mentioned earlier. As this massive silhouette passes in front of distant stars, its sheer weight is warping the space-time around it. It's acting like a giant magnifying glass, bending the light of the universe. This tells the team at the Keck Observatory in Hawaii that whatever this thing is made of, it is incredibly dense. We're talking about a density that rivals the core of a star, packed into a shape that is steering itself toward a human-made machine. The scale of the displacement is causing a localized mess in the outer solar system. We're seeing impact flashes in the distance, where the shadow's gravity is pulling smaller icy bodies together, causing them to collide and shatter. It's leaving a trail of destruction in its wake, a path of pulverized ice and dust that marks its progress toward the 3i, Atlas. We've never seen a natural event create such a focused linear path of chaos. Usually, gravity pulls in all directions, but this force is focused, almost like a wake behind a ship. We've started looking at the 3i, Atlas's onboard magnetometer, and the readings are off the charts. As the silhouette gets closer, the magnetic field around the probe is being twisted. It's as if the object has a magnetic personality that's trying to handshake with our tech. There's a theory floating around the Harvard-Smithsonian Center for Astrophysics that this isn't just a physical encounter. If this object is non-ballistic and light-consuming, it might be looking for a source of information. And right now, 3I, Atlas, is the only chatty thing in that part of the woods. The challenge we have now is that we're running out of time to get a clear image. Because the object absorbs the solar spectrum so perfectly, we're essentially trying to photograph a black cat in a coal cellar during a power outage. Our only hope is the occultation method, waiting for it to pass in front of a very bright star and using the distorted light to map its edges. But as it continues to make those non-ballistic course corrections, it's proving to be a moving target that doesn't want to be measured. As we look closer at the deep space imaging coming back from the James Webb Space Telescope, the term shadow starts to feel like an understatement. It's more like a puncture wound in the sky. When the telescope centers on the 3I Atlas coordinates, what we see isn't a solid object with craters or mountains. We see a localized void. It's a patch of space where the background star field simply ceases to exist. Usually, when a planet or a moon passes in front of stars, you can see a tiny bit of reflected light on its edges, a crescent or a glimmer. But this silhouette is different. It consumes every single photon of light that touches it. There's no bounce, no glow, and absolutely no heat signature. This is causing a massive headache for the teams at the European Southern Observatory. They've been trying to run a spectral analysis, which is basically a way of seeing what something is made of by looking at the light it reflects. But since there's no reflected light, the readout comes back as a flat line. It's like the universe's most perfect black hole, except it's not a black hole. It's too small for that, and it's moving far too precisely. We're speculating on a material composition that can displace the frozen debris of the Oort cloud while remaining totally invisible to infrared sensors. Some of the theorists at the Harvard-Smithsonian Center for Astrophysics are wondering if we're looking at a structure coated in something like vantablack, but on a cosmic scale, a surface designed to eat light so it can move through the dark without being spotted. The scale of this thing is what really gets you. As it moves, it's causing a localized gravitational lensing effect. Now, normally, you need something as heavy as a galaxy to bend light. But this object is so incredibly dense that it's warping the image of the stars behind it. If you were looking through a telescope, the stars wouldn't just disappear. They would appear to stretch and swirl around the edges of the void, like water going down a drain. This tells the researchers at the Keck Observatory in Hawaii that we aren't just dealing with a big rock. We are dealing with something that has a mass to volume ratio that shouldn't exist in nature. It's compact, it's heavy, and it's steering. Think about the sheer amount of energy it takes to move something that massive. In space, if you want to change direction, you have to push against something or eject mass like a rocket engine. But the 3I Atlas sensors aren't picking up any chemical plumes or ion trails. There's no exhaust. This silhouette is rewriting the laws of physics right in front of our eyes. It's displacing ancient ice and steering toward our probe using a propulsion method that doesn't leave a footprint. It's as if it's sliding through the fabric of space-time rather than pushing through it. The 3I Atlas probe is now close enough that its own internal clocks are starting to drift. This is a classic sign of intense gravitational interference. According to the latest telemetry data from the Jet Propulsion Laboratory, the probe is experiencing a gravitational drag that wasn't there a week ago. The closer the silhouette gets, the more the probe struggles to maintain its own orientation. It's like a small boat being pulled into the wake of a massive ocean liner that you can't actually see. You just feel the pull, and you see the water churning, but the ship itself is a ghost. NASA's Deep Space Network is now running 24/7 coverage of this sector. We're pulling in every bit of data we can from the Vera Rubin Observatory to map the debris wake left behind by the object. By looking at how the ice in the Oort cloud is being tossed around, we can start to estimate the object's actual shape. And the shape isn't a sphere. It's not a jagged asteroid. The displacement patterns suggest something long, symmetrical, and sharp. It's a silhouette that looks more like a tool than a moon. Every time the 3I Atlas tries to snap a high-gain photo, the image comes back garbled with noise. It's not just that the object is dark. It seems to be emitting a localized field that interferes with electronic imaging. This is a huge challenge for the mission. How do you study something that is actively hiding from your tools? We've reached out to the team managing Stanford's Ronald Bracewell radio astronomy concepts to see if we can use radio waves to ping the object, much like a submarine uses sonar. But so far, the pings just vanish. They go out, but they never come back. The object isn't just absorbing light, it's absorbing radio waves too. The question everyone is asking at the Goddard Space Flight Center is, why now? Why has this entity spent billions of years in the frozen depths of the Oort Cloud only to wake up and head for a human probe in 2026? We're looking at a non-ballistic entity that is actively choosing its path. This isn't a random encounter. This is a meeting. And as the shadow continues to displace the ancient debris of our solar system's backyard, we have to face the reality that our understanding of natural celestial bodies might be completely wrong. The team at the Jet Propulsion Laboratory started noticing a secondary effect that is blowing the collective minds of the astrophysics community. As this void moves, it isn't just pushing the ice aside, it's actually dragging a wake of ghost particles behind it. When we look at the telemetry data from the 3I, Atlas's high-energy particle detector, we see a massive spike in neutrinos. Now, for those of you who aren't science nerds, neutrinos are tiny particles that usually pass through everything, including you, me, and the entire Earth without stopping. They are notoriously hard to catch. But as this silhouette steers toward the probe, it's generating a density of neutrinos that suggests a power source far beyond anything we've ever theorized. Stanford's Ronald Bracewell once proposed the idea of automated messengers, or lurkers, that might sit in the cold corners of a solar system for millions of years, waiting for a sign of life. If this thing is a Bracewell probe, it's a terrifyingly large one. The scale of the displacement in the Oort Cloud is now being mapped by the Vera Rubin Observatory's latest survey, and the path this thing is carving is over 50,000 miles wide. That is 4 times the diameter of Earth. We are talking about a colossal presence that makes our biggest planets look like marbles. And yet, despite that size, the 3I Atlas can't see it. The light-consuming nature of the object is so absolute that it's creating a blind spot in the sky. If you were sitting on the 3I Atlas right now, looking out the window, you wouldn't see a ship or a planet. You would see a circular patch of the universe where the stars have simply been deleted. It's a localized vacuum of information. Even the cosmic microwave background radiation, the afterglow of the Big Bang that fills all of space, is being swallowed up by this thing. This brings up a massive problem for the navigation team. How do you avoid a collision with something you can only track by the absence of everything else? The 3I Atlas is currently trying to use its thrusters to move laterally sideways to see if the shadow follows. And the results are chilling. Every time the probe shifts its position by even a few kilometers, the shadow adjusts its non-ballistic trajectory within seconds. There is a lag, of course, because of the distance. But the intent is clear. It is locking on. Researchers at the Max Planck Institute for Astronomy have joined the effort using data from the Keck Observatory in Hawaii to see if there's any gravitational leakage. They found that the object's mass isn't constant. This is where the laws of physics start to really break down. As the silhouette moves faster, its gravitational pull seems to fluctuate. In our world, mass is mass. You don't just get heavier because you're in a hurry. But this entity is displacing more and more Oort Cloud debris as it accelerates, almost as if it's feeding on the matter it encounters to generate its own propulsion. It's a terrifying thought. A light-consuming void that eats the very debris of our solar system to fuel its journey toward us. We've been looking at the Arecibo legacy data from the late 90s, trying to see if there were any ghost signals from this sector back then. Interestingly, there was a recorded dark transit noted by astronomers at the time, but it was dismissed as a sensor error or passing cloud of dust. Now, 30 years later, we're realizing it might have been the same entity, just moving much slower, waking up from a long sleep. The 3i Atlas probe is our only tether to this reality. It's equipped with a plasma wave instrument designed to listen to the sounds of space. As the shadow closes the gap, the audio files being sent back to the deep space network are haunting. It's not the usual hiss of solar wind or the crackle of a magnetosphere. It's a rhythmic, low-frequency pulse. It sounds like a heartbeat, if a heartbeat could be made of thunder and metal. Engineers at NASA are currently trying to decode if there's a pattern in these pulses, a handshake of some kind, or if it's just the raw sound of space-time being torn apart by the object's sheer mass. Meanwhile, the gravitational lensing is getting worse. Because the object is so dense, it's actually magnifying the 3i Atlas probe from certain angles, making the probe appear larger to our Earth-based telescopes than it actually is. It's an optical illusion caused by the warping of space. We are literally seeing the universe bend around this intruder. It's a colossal shadow that doesn't just block the light, it distorts the very fabric of the where and when in the outer solar system. The question we have to answer is, if it's not a comet, and it's not a planet, and it's steering, what is the mission? Why the 3i Atlas? Why now? The probe wasn't carrying any weapons or even any complex AI. It was a simple surveyor. But maybe to something that has lived in the dark for 1 billion years, even a simple flashlight looks like a declaration of war, or worse, an invitation. To get a real sense of why the 3i Atlas telemetry is causing such a panic at the Goddard Space Flight Center, you have to look at the light, or the lack of it. When we point our most powerful tools, like the Keck Observatory in Hawaii, at the coordinates where the gravity spike is strongest, we don't see a solid surface. We see a localized void that is actively obscuring background star fields. It's not just a shadow. It's a light-consuming silhouette that seems to drink in every photon that touches it. In our normal experience, everything reflects something. Even a piece of coal reflects a tiny bit of light. But this thing, it has a surface that perfectly absorbs the solar spectrum. This leads to a massive problem for the team at the Harvard-Smithsonian Center for Astrophysics. If you can't see the object's surface, you can't see what it's made of. There's no heat signature for our infrared telescopes to latch onto. Usually, even a frozen comet out in the Oort Cloud has a temperature of a few degrees above absolute zero. That tiny bit of heat shows up like a beacon to the James Webb Space Telescope. But the 3i Atlas mission reports show a thermal dead zone. Whatever this colossal entity is, it's not just cold, it's thermally silent. It's as if it's using the frozen debris it displaces as a shield, or perhaps its very skin is designed to hide from the laws of thermodynamics. The scale here is hard to wrap your brain around. We aren't talking about a city-sized asteroid. Based on how much of the background universe it's blocking out, this silhouette is roughly the size of a small moon, yet it has the gravitational weight of a much larger planet. This massive scale is causing a localized gravitational lensing effect. This is usually something we only see with black holes or distant galaxies. The gravity of this object is so intense that it's actually bending the light of the stars behind it, creating a warped, halo-like ring of distorted space-time around the void. Scientists at Stanford, looking at the Ronald Bracewell radio astronomy concepts, are starting to wonder if we are seeing a Bracewell probe on a scale we never imagined. Bracewell's theory suggested that an advanced intelligence might send out automated lurkers to wait in the quiet corners of a solar system. If this thing is a lurker, it's a big one, and it's no longer waiting. It's moving. And it's moving in a way that is causing the 3i Atlas probe's trajectory to wobble as if it's being pulled into a giant's wake. The 3i Atlas probe was originally sent out to study the interstellar comet 3i, but now the probe itself has become the hunted. As this colossal shadow steers directly toward the probe's path, the 3i Atlas is sending back data that looks like it belongs in a sci-fi movie. We're seeing non-ballistic adjustments. In space, if you want to turn, you need a thruster or a huge gravity well. This object is turning in the middle of nowhere, with no visible exhaust and no chemical signature. It's effectively rewriting the laws of orbital mechanics as we know them. It's not falling, it's navigating. NASA's Deep Space Network is currently trying to keep a lock on the 3I, Atlas's signal. But the closer the shadow gets, the more the signal flickers. It's not just radio interference. It's the gravity. The gravitational lensing is so strong that the radio waves themselves are being bent and delayed. We're literally losing our grip on reality the closer this thing gets. There's a quiet tension in the mission control rooms right now. No one wants to say the word artificial, but when you see a moon-sized shadow making a 3-point turn in the Oort Cloud, natural stops being a good explanation. What's really keeping the engineers at the NASA Jet Propulsion Laboratory up at night isn't just that this thing is big, it's that it's smart. Or at least, it's acting with a level of precision that we usually only see in programmed machines. When we look at the telemetry data from the 3I Atlas, we're seeing non-ballistic adjustments that defy everything we know about orbital mechanics. In a vacuum, if an object doesn't have an engine, it follows a path set by gravity. It's like a train on a track. But this shadow is switching tracks. It's making active course corrections that distinguish it from a standard long-period comet or even a rogue planet. The primary piece of evidence for this comes from the way the silhouette is interacting with the 3I, Atlas probe itself. As a probe moves through the outer fringes of the Oort Cloud, the shadow is maintaining a constant intercept vector. If the probe speeds up, the shadow adjusts. If the probe shifts its angle to get a better look at a distant star cluster, the shadow moves to maintain its position as a blind spot. This kind of behavior is something we've only theorized about in papers from the Harvard-Smithsonian Center for Astrophysics regarding autonomous deep space monitors. It's as if the object is trying to stay exactly between us and whatever lies further out in the dark. And then there's light, or the total lack of it. Deep space imaging from the James Webb Space Telescope reveals a localized void that obscures background star fields without emitting a single detectable heat signature. Now, usually when something blocks out a star, we can see its silhouette because of the infrared glow of its own internal temperature. Even a frozen rock has some heat. But according to the latest records from the European Southern Observatory, this object is a perfect absorber. It's drinking in the solar spectrum like a sponge and giving nothing back. This suggests a surface material that isn't just dark, it's engineered to be invisible to every sensor we have. This leads to a chilling speculation on the material composition. To displace thousands of tons of ancient Oort Cloud debris while remaining invisible to infrared telescopes, you'd need a hull that can manage heat in a way that breaks our current understanding of thermodynamics. We are seeing a massive scale object, roughly the size of a large moon, causing a localized gravitational lensing effect. This means the object is so heavy, it's actually bending the light of the universe around it, distorting our view of the outer solar system. It's like looking through a magnifying glass that's been painted black. Researchers at the Vera Rubin Observatory are currently mapping the gravitational wake left behind by this entity. By watching how the surrounding icy bodies are tossed around, they've calculated that the object's mass is fluctuating. This is another impossible detail. In nature, mass stays the same, unless you lose a chunk of yourself. But this silhouette seems to be tuning its gravity, perhaps as a way of steering without using traditional thrusters. It's a technology that looks like magic to us, but it's happening right now, trillions of miles away. The 3I, Atlas probe, is currently our only eyes on the situation, and it's sending back ghost signals. These are radio bursts that don't match any known natural phenomena. We've compared them to the Arecibo legacy data, and even some of the more out-there concepts from Stanford's Ronald Bracewell about interstellar communication. The pulses are rhythmic, almost like a heartbeat, and they seem to be increasing in frequency as the distance between the probe and the shadow closes. It's a countdown that nobody invited, happening in a place where no one was supposed to be watching. The absence of any reflected light or thermal radiation has forced us to rely on occultation studies. This is when we wait for the object to pass in front of a distant bright star so we can measure its edges. But every time we think we have a lock on it, the shadow makes another one of those non-ballistic maneuvers. It's dodging our measurements. It's as if it knows it's being watched and is choosing to remain a mystery. At this point, the mission isn't just about discovery anymore. It's about understanding the intent of an entity that is actively rewriting the laws of physics to stay in the shadows. The sheer density of this object is creating a secondary problem that is baffling the mission specialists at the Vera Rubin Observatory. It's not just that the shadow is heavy, it's that its mass seems to be unfettered. When we look at the displacement of the inner Oort cloud, we see a trail of debris that looks like a miniature spiral galaxy. Recent studies, including those published early in 2026, suggest the Oort cloud itself might have a spiral disk structure rather than a simple sphere. But this silhouette is cutting right through those spiral arms, ignoring the natural tidal forces of the Milky Way that usually dictate how these icy bodies move. It is effectively a gravity anchor moving through a field of dust, and the wake it leaves behind is a perfect linear scar across the sky. This brings us to the most uncomfortable realization of the 3I Atlas mission. We've all seen interstellar objects before. Think back to Oumuamua or 2I, Borisov. Those were weird, sure, but they followed the rules of high-speed, hyperbolic trajectories. They came in fast, swung around the sun, and headed back out. But the 3I Atlas data shows this silhouette is slowing down. It has a hyperbolic excess velocity that should be carrying it away at 61 kilometers per second. Yet its current speed is dropping in a way that gravity alone cannot explain. It is braking. At the Keck Observatory in Hawaii, astronomers are using adaptive optics to try and see if there is any structural detail within the void. What they found is a phenomenon known as negative polarization. Basically, the very little light that does manage to bounce off the edges of the silhouette isn't behaving like light reflecting off a rock. It behaves like light hitting a complex microscopic lattice. Think of it like this. If you shine a flashlight on a mirror, the light bounces back. If you shine it on this object, the light is twisted, bent, and essentially captured. It's as if the surface is a trap for information. This has led to a flurry of emergency meetings between the Jet Propulsion Laboratory and the European Southern Observatory. The 3I Atlas probe is now sending back what we call ghost telemetry. These are packets of data that contain the probe's own location, but with a timestamp that is slightly off. Remember that gravitational lensing we talked about? It's now so intense that the radio signals from the probe are being delayed by the curvature of space around the shadow. We are literally watching the probe fall into a gravity well that shouldn't be there. Stanford's Ronald Bracewell once talked about lurkers, autonomous probes that stay hidden in the noise of a solar system for eons. The theory was that they would use a stealth profile to observe us without interfering. But this shadow has dropped the act. It is no longer a lurker. It is a rendezvous entity. The way it is steering directly toward the 3I, Atlas suggests that our little probe triggered a protocol. Maybe it was the specific radio frequency we used. Or maybe it was the fact that 3I Atlas is the first human object to reach this specific coordinate in the deep Oort cloud. The material of the silhouette remains the biggest mystery. Some scientists are looking at vantablack technology, the darkest man-made material, and wondering if we're seeing a cosmic version. Vantablack is made of carbon nanotubes that trap light. If this silhouette is covered in a similar structure, it would explain why the James Webb Space Telescope sees a void instead of a surface. But to do this on a scale the size of a moon, the engineering required is beyond anything in our textbooks. We are looking at a light-consuming hull that can withstand the crushing gravity of its own mass, while maintaining a perfect, light-eating exterior. Meanwhile, the clutter of the Oort cloud is being sucked into the shadow's wake. The Arecibo legacy data suggested that there were anomalous echoes in this sector years ago, but we didn't have the 3I Atlas out there to act as a witness. Now we do. And as the probe sensors begin to max out, we're realizing that the shadow isn't just a physical object. It's a focal point for a set of physics we haven't even named yet. The localized void is expanding, not because the object is growing, but because its influence over the surrounding light and space is becoming more aggressive as it approaches the 3I Atlas. What's making the scientists at the NASA Jet Propulsion Laboratory particularly nervous is that this isn't just a physical encounter, it's a structural one. We've started to notice that the shadow isn't just displacing the Oort cloud debris, it's actually sorting it. Usually, when a large mass moves through a field of ice, it creates a chaotic mess, a random scattering of rocks and gas. But the Vera Rubin Observatory's high-cadence surveys are showing a wake that is mathematically organized. It's as if the object's gravitational field is acting like a fine-toothed comb, pulling specific materials toward it while discarding others. This brings up a fascinating, if slightly terrifying, theory from the team at the Harvard-Smithsonian Center for Astrophysics. They've been looking at the spectroscopic records from the James Webb Space Telescope and noticed that the space behind the silhouette is cleaner than it should be. It's as if this light-consuming entity is vacuuming the interstellar medium as it moves. We call this a Bussard ramjet concept in theoretical physics, a way for a spacecraft to gather fuel from the vacuum of space itself. If this entity is using the Oort cloud as a gas station, it explains why it's able to maintain such a high non-ballistic velocity without any visible exhaust. And the 3I Atlas probe is right in the crosshairs of this intake path. We've seen its internal temperature sensors start to spike, not because of sunlight, but because of frictional heating from the sheer density of particles being dragged along by the shadow's wake. It's like the probe is suddenly trying to fly through a thick fog instead of a vacuum. According to data from the Keck Observatory in Hawaii, the gravitational lensing around the object is now creating a halo effect that is actually magnifying the sun's light in a very narrow beam aimed directly at the 3I Atlas. It's as if the shadow is using the sun itself as a searchlight to keep our probe in clear view. Researchers at Stanford, following up on the Bracewell radio astronomy concepts, have noticed a change in the rhythmic pulses we've been tracking. They're no longer just low-frequency thumps. They've evolved into a complex, multi-layered signal. We've cross-referenced this with Arecibo legacy data to see if we've ever picked up anything similar from deep space. The results are inconclusive, but there's a pattern emerging that looks suspiciously like a handshake protocol. It's a series of binary bursts that match the mathematical constants for hydrogen, the most common element in the universe. It's the ultimate hello in a language that doesn't use words. But why talk to a probe? 3I, Atlas is a machine, not a diplomat. One chilling possibility being discussed at the European Southern Observatory is that the shadow isn't interested in the probe's mission. It's interested in its origin. By tracing the radio signal back to Earth, this entity could be using 3I, Atlas, as a breadcrumb trail. The localized void is now so close that the 3I, Atlas's cameras are completely washed out by a total lack of signal. It's like the probe is staring into a black hole that isn't a black hole. We're also seeing a warping of the 3I, Atlas's physical structure. As the localized gravitational distortions get stronger, the probe's metal frame is actually stretching by a few millimeters. This is tidal force in action, and it usually only happens when you get too close to a massive planet like Jupiter. But here, in the middle of the Oort cloud, it's being caused by a silhouette that we still can't even see. This object's mass-to-volume ratio is so high that it's literally pulling the atoms of our technology apart before it even makes contact. The mission team is now in a limited communication phase. We're only getting small bursts of data every 6 hours because the curvature of space around the object is making it harder for the probe's high-gain antenna to stay locked on Earth. We're basically watching a live feed of a car crash in slow motion, except the car is 5 billion miles away and the wall it's hitting is a light-consuming ghost that shouldn't exist. The question now isn't if the 3I Atlas will survive the encounter, but what it will see in the final milliseconds before the void closes in. As we move deeper into the data, the mystery behind the 3I Atlas's struggle reveals something even more bizarre. The shadow is starting to show a geometry. For months, we've just called it a void or a silhouette. But the latest mapping from the Vera Rubin Observatory has detected something called occultation fringing. This happens when light from a distant star bends around the sharp edge of an object. If this were a round planet or a jagged comet, the light would scatter in a messy, predictable way. But the light hitting the 3i Atlas sensors is snapping around corners that are perfectly straight. We are talking about right angles on a scale of hundreds of miles. This discovery has sent a shockwave through the European Southern Observatory. Nature doesn't usually build things with straight lines and 9 0-degree corners, especially not in the chaotic, frozen debris of the Oort Cloud. When we look at the way this entity is displacing the ice, it's not just pushing it, it's channeling it. The wake left behind the object isn't a cloud of dust, it's a series of parallel streams. It looks like the slipstream behind a high-performance aircraft, but scaled up to a size that could swallow our moon. The team at the Keck Observatory in Hawaii has been trying to use laser ranging to get a solid bounce off the surface. Normally, you fire a laser, it hits the target, and it comes back telling you exactly how far away it is. But when we fired the pulse toward the 3i Atlas coordinates, the light didn't just fail to return, it shifted. The frequency of the laser light changed from green to a deep, bruised purple. This is gravitational redshift. It means the gravity of this object is so intense that it's literally stretching the light waves as they try to escape its pull. It's a phenomenon usually reserved for the most extreme environments in the universe, like the edge of a neutron star. At the Harvard-Smithsonian Center for Astrophysics, the conversation has shifted from what is it to how is it doing this? If the object has the mass of a planet, but the shape of a structured craft, the material would have to be something we've only seen in the most advanced labs at Stanford. We're talking about metamaterials, substances engineered to have properties that don't occur in nature. This would explain why the object is light-consuming. It's not just dark paint. The very skin of this entity is designed to guide light around it or soak it up like a sponge, making it invisible to the James Webb Space Telescope's infrared eyes. The 3i Atlas probe is now reaching a critical point in its mission. Its internal inertial measurement units are reporting that the probe is being rotated. It's not the thrusters doing it. The shadow's gravitational lensing is so powerful that it's creating a torque on the probe. It's like the 3i Atlas is being caught in a whirlpool in space. As the probe spins, its cameras are catching brief, strobing glimpses of the stars being stretched into long, thin lines of light. Even more startling is the data coming from the Hubble spectrograph records we've been using as a baseline. When we compare the chemical fingerprint of the Oort Cloud from 10 years ago to the area surrounding the shadow now, there's a massive missing chunk of carbon and silicates. This entity is literally eating the raw materials of our solar system. It's not just a visitor, it's a consumer. It's using the ancient debris of the Oort Cloud as a source of mass, perhaps to repair itself or to fuel its non-ballistic maneuvers as it prepares for its next move toward the 3i Atlas. NASA engineers are now trying to blind fire a radio message using the Deep Space Network, hoping that even if the object absorbs the signal, the 3i Atlas might pick up the echo. But the localized void is becoming so dense that it's creating a communication blackout. We are watching the most important event in human history through a keyhole that is slowly being painted over. Every bit of data we manage to pull out before the final intercept is a treasure, a clue to a technology that is actively rewriting the laws of physics right in our own backyard. What is really shaking the foundation of the team over at the NASA Jet Propulsion Laboratory is the discovery of density pockets within the shadow. Using the 3i, Atlas's high-frequency gravitational wave detector, an instrument normally used to find distant black hole collisions, we've started to ping the internal structure of the entire silhouette. What we found isn't a solid rock. It's a honeycomb of varying densities. There are sections of this moon-sized object that are as light as a cloud, and others that are so dense they actually cause the probe's onboard atomic clocks to desynchronize by several nanoseconds every hour. This level of structural complexity is something you just don't see in nature. When the European Southern Observatory looked at the gravitational wake again, they realized the object isn't just displacing ice. It's pulling in specific isotopes of helium, 3 from the Oort Cloud debris. If you know anything about fusion power, you know helium. 3 is the holy grail of clean energy. The fact that this non-ballistic entity is selectively mining the debris as it steers toward 3I, Atlas, suggests that it isn't just a shadow, it's a functioning, power-hungry machine. It's literally refueling on its way to the meeting point. The Keck Observatory in Hawaii has also detected a strange shimmer on the very edge of the void. Because the object is a light-consuming silhouette, we usually see nothing. But as it passes through thicker patches of gas, the gas is being ionized. It's glowing with a ghostly blue light. This tells us the object has a massive electromagnetic field. We're talking about a field so strong, it makes Jupiter's magnetosphere look like a toy magnet. This field is likely what it uses to steer without thrusters, interacting with the sun's own magnetic field lines that stretch all the way out to the Oort Cloud. Now, researchers at the Harvard-Smithsonian Center for Astrophysics are comparing these findings with the Arecibo legacy data from the 1990s. Back then, there was a recorded unidentified radio source in the same sector that was dismissed as a pulsar. But when we look at it today, the timing of those pulses perfectly matches the current heartbeat signal we're getting from 3I Atlas. This means this colossal entity has been out there, active, and drawing power for at least 30 years. It hasn't just arrived, it's been waking up. The 3I Atlas probe is now feeling the thermal pinch, even though the shadow itself emits no heat. The magnetic friction it's creating in the surrounding space is causing the probe's exterior to warm up. We're seeing a rise of about 10 degrees every few hours. For a probe built to operate in the absolute zero of the Oort Cloud, this is a death sentence for its delicate instruments. The team at Stanford, using the Ronald Bracewell radio astronomy concepts, believes the shadow might be trying to capture the probe using this magnetic field rather than destroying it. It's as if a giant invisible hand is reaching out to grab a tiny buzzing fly. As the light-consuming silhouette grows larger in the 3I Atlas's dead-ahead sensors, the gravitational lensing is starting to create what we call an Einstein ring. This is where the light from the entire galaxy behind the object is bent into a perfect circle of fire around the blackness of the void. It's a beautiful, terrifying sight that confirms the object's massive scale. We are watching the laws of physics rewrite themselves in real time as the void prepares to make its final maneuver. The displacement of the Oort Cloud is reaching a peak, and the path behind the object is now a perfectly clear tunnel through the ice aimed straight back at the inner solar system. What's really starting to rattle the researchers at the Vera Rubin Observatory is how the surrounding space is reacting to this void. We aren't just seeing a shadow anymore. We're seeing a cavitation effect. In fluid dynamics, cavitation happens when an object moves so fast through a liquid that it leaves a bubble of vacuum behind it. But this is happening in the vacuum of space. The 3I Atlas is reporting that the density of the interstellar medium, the thin gas and dust between stars, is dropping to zero in front of the silhouette. It's as if the object is inhaling the vacuum itself before it even arrives. This leads us to a massive challenge regarding the object's internal power. According to the latest readings from the 3I Atlas's gamma-ray spectrometer, there is a rhythmic flicker of high-energy radiation coming from the center of the void. It's not a steady glow like a star. It's a pulse, occurring every 1.4 seconds. Scientists at the Max Planck Institute for Astronomy have noted that this frequency is far too precise to be a natural pulsar. When you combine this with the non-ballistic steering, the picture becomes clear. We're looking at a machine that is idling. It's like hearing the low rumble of a massive engine while the ship is still drifting. The scale of the gravitational lensing has now reached a point where it's actually distorting our own telemetry. As the 3I Atlas sends its data packets back to the Deep Space Network, the radio waves are being stretched so much that the data is arriving at Earth in slow motion. We have to use a complex algorithm, originally developed by the Harvard-Smithsonian Center for Astrophysics for studying black holes, just to piece the message back together. What we're finding in those fragments is terrifying. The 3I Atlas isn't just being pulled, it's being scanned. The probe's onboard magnetometer is picking up a series of structured electromagnetic pings. These aren't random noise. They're incredibly focused beams of energy that seem to be mapping the 3I Atlas's internal components, from its plutonium power source down to its copper wiring. It's the cosmic equivalent of a customs officer looking through your luggage. The silhouette has stopped its aggressive displacement of the Oort cloud and has entered a shadowing phase, where it has matched the probe's speed and direction perfectly, despite the fact that the probe is currently traveling at over 40,000 miles per hour. This is where the absence of thermal radiation becomes a major clue. If this were a natural rock, the scanning energy would cause its surface to heat up. But the European Southern Observatory reports that the silhouette remains at a constant, impossible temperature. It is absorbing the energy it's using to scan us. This suggests a level of energy recycling that we've only seen in theoretical papers at Stanford. The object isn't wasting a single watt of power. It is a closed system, a light-consuming entity that treats the entire solar spectrum as a buffet. The 3I Atlas mission was supposed to be a quiet scouting trip. But now it's become the first point of contact with a technology that doesn't just use the laws of physics, it bends them to its will. The localized void is now so large that it's beginning to obscure our view of the sun from the probe's perspective. For the 3I Atlas, the sun has effectively gone out. In its place is a towering, light-drinking wall of geometry that is currently rewriting what we thought was possible in the frozen depths of our own backyard. While the engineers at the NASA Jet Propulsion Laboratory are staring at their monitors in disbelief, the situation has shifted from a mere observation to a physical disturbance. The 3I Atlas isn't just seeing the shadow, it is feeling it. We are seeing a phenomenon that scientists at the Keck Observatory in Hawaii are calling spatiotemporal dragging. As the silhouette steers closer, the very space-time around the probe is being pulled along with it. It's like a massive ship moving through water. It doesn't just pass you, it creates a current that sucks everything into its wake. This is having a bizarre effect on the probe's communication equipment. The radio waves aren't just being bent by gravity, they're being frequency locked. Every signal the 3I Atlas tries to send back to the Deep Space Network is being flattened into a single, monotonous tone. It's as if the silhouette is putting its hand over the probe's mouth. Researchers at the Harvard-Smithsonian Center for Astrophysics have pointed out that this isn't just a side effect of mass. It looks like an intentional information quarantine. The object is effectively cutting the 3I Atlas off from the rest of the solar system before the final intercept happens. The localized void has now expanded to the point where it covers nearly 30 degrees of the probe's field of vision. To give you an idea of how big that is, if you held your hand out at arm's length, this shadow would be twice as wide as your palm. And yet, there is still no light. No reflections of the sun, no glow from internal lights, no heat. But the Vera Rubin Observatory has picked up something new: glinting. Occasionally, as the object displaces a particularly large chunk of Oort cloud ice, a tiny flash of light occurs on the edge of the void. These flashes aren't reflections, they are synchrotron radiation. This happens when electrons are accelerated to near the speed of light by a massive magnetic field. This confirms what the team at Stanford's Ronald Bracewell radio astronomy concept suspected. The silhouette is wrapped in a magnetic shield so powerful that it's ionizing the very vacuum of space. It's using the frozen debris of the Oort cloud as a source of ions to maintain this shield. It's a self-sustaining, light-consuming engine that treats the edge of our solar system as a giant fuel tank. We've also started to see the first structural shadow during a rare stellar occultation. As the object passed in front of a bright star in the Orion Nebula, the 3I Atlas caught a high-speed frame of the silhouette's edge. It wasn't smooth, it was fractal. The edge of the object is covered in millions of tiny, needle-like structures, each one designed to trap and dissipate incoming energy. It looks like a giant, dark snowflake made of obsidian. This explains why the European Southern Observatory couldn't find a heat signature. The surface is designed to radiate heat inward or convert it into propulsion energy. The 3I Atlas's onboard computer is now struggling to keep its orientation. The non-ballistic movements of the shadow are creating a gravitational shear, a difference in gravity between the front of the probe and the back. This is literally trying to stretch the 3i Atlas like a piece of taffy. We've had to engage the emergency stabilization gyros, which are normally reserved for high-speed planetary flybys. But we aren't flying by a planet. We're being stalked by a shadow that is rewriting the laws of physics 1 mile at a time. NASA's Goddard Space Flight Center is currently trying to coordinate with the European Southern Observatory to see if we can use multi-messenger astronomy to get a better look. This means using gravity, waves, light, and particles all at once. But the shadow seems to be one step ahead. Every time we change our observation method, the silhouette adjusts its active course corrections to present its most invisible side to Earth. It's a game of cosmic cat and mouse. And right now, the mouse is a multi-million-dollar probe, and the cat is a moon-sized entity that can eat light. As the distance between our scout and the intruder narrows, the 3i Atlas has begun to experience gravitational echoes that are completely baffling the team at the NASA Jet Propulsion Laboratory. When the probe fires its deep penetrating radar, the same kind of tech we use to map the subsurface oceans on Europa, the signal doesn't just bounce back, it echoes internally. This suggests that the void isn't a solid mass at all, but a hollowed out shell of immense complexity. It's as if the silhouette is a massive, light-consuming cathedral of dark matter, housing a core that is far more active than its cold exterior lets on. Researchers at the Max Planck Institute for Astronomy have been comparing this hollow data with the Arecibo legacy data from the 1990s, and they found something chilling. The gravitational signature of this sector has changed. It's as if the object has been inflating or building itself up using the Oort Cloud debris as raw material. This fits with the theory from the Harvard-Smithsonian Center for Astrophysics that we are looking at a self-replicating machine. It isn't just steering toward the 3i Atlas. It is evolving as it moves, using the displacement of ancient ice to craft new layers of its light-drinking hull. The 3i Atlas's onboard magnetometer is now picking up flux ropes. These are twisted bundles of magnetic field lines that usually connect the sun to the planets. But here, they are connecting the silhouette to the 3i Atlas. It's a physical magnetic tether. The probe is being dragged along by an invisible leash. According to the telemetry from the European Southern Observatory, the probe's velocity is now being perfectly slaved to the shadow. This is the ultimate non-ballistic behavior. The object has captured a human-made object without firing a single shot or using a single tractor beam. It has simply rewritten the gravity in the room. Back at the Vera Rubin Observatory, astronomers are noticing that the gravitational lensing is starting to affect the light from our own sun as seen from the edge of the solar system. The sun, which should be a bright, steady point of light, is appearing to flicker in the 3i, Atlas's rear sensors. This isn't because the sun is dying. It's because the shadow's gravity is so intense, it's creating a lens that is focusing and defocusing the sunlight in a rhythmic pattern. It's like a lighthouse beam, but the light is being bent by a moon-sized entity that refuses to show its face. This has led to a major information gap in our mission. Because the gravity is so heavy near the probe, time dilation is becoming a factor we can no longer ignore. For every hour that passes on Earth, the 3i, Atlas's internal clock, is losing about 5 milliseconds. That might not sound like much, but in the world of high-speed space travel and radio synchronization, it's a disaster. It means our live feed from the probe is actually arriving from a slightly different when. We are watching the 3i, Atlas, slip into a pocket of time that belongs entirely to the shadow. NASA's Goddard Space Flight Center is now looking at the structural reveal coming through the debris wake. As the shadow pulls in ice and dust, it leaves behind a refined trail of pure oxygen and hydrogen. It's as if the object is a giant chemical plant, stripping the Oort Cloud of its useful elements and discarding the rest in a perfectly straight line. This confirms that the entity isn't just a silhouette. It is a purposeful, industrial-scale presence. It's not just rewriting the laws of physics. It's harvesting the solar system's backyard to sustain a journey that started long before humans even had telescopes. While we've been staring at the edge of the solar system, the shadow has finally started staring back. In a move that has paralyzed the team at the NASA Jet Propulsion Laboratory, the 3i, Atlas's low-light cameras just caught the first optical leak. For months, this thing has been a total void. But as it crossed a specific gravitational threshold, a series of faint geometric lines began to glow beneath the surface of the light-consuming hull. It's not a glow we recognize from any light bulb or star. It's a deep, rhythmic amber that pulses in sync with the gravity spikes we're feeling back home. This brings us to a terrifying development. The gravity sensors across the globe aren't just spiking anymore, they're ringing. Research teams at Stanford, using the Ronald Bracewell radio astronomy concepts, have confirmed that these pulses are traveling faster than the speed of light through a process called quantum entanglement of space-time. This means that the shadow isn't just a physical object moving through the Oort cloud. It's a localized anchor that is pulling on the entire solar system. On Earth, high-precision satellites in geostationary orbit are having to fire their thrusters just to stay in place because the pull from the Oort cloud is actually shifting the planet's center of mass by a fraction of a millimeter. The European Southern Observatory has released a report showing that the localized void is no longer just absorbing light, it's rebroadcasting it. As the 3I, Atlas, gets closer, the light of the sun is being captured by the silhouette, processed, and then emitted as a highly focused beam of neutrinos. We've never seen a material that can convert photons into neutrinos with such high efficiency. This suggests that the silhouette isn't just a hull, it's a giant solid-state energy converter. It's turning our own sun's energy into a propulsion system that allows it to maintain its non-ballistic maneuvers without losing a single ounce of momentum. Back at the Keck Observatory in Hawaii, the atmospheric distortion is making it harder to track, but the data we do have shows that the 3I Atlas is now being escorted. The shadow has moved from behind the probe to a position right alongside it. The gravitational lensing is so extreme now that from Earth's perspective, the 3I Atlas looks like it has been duplicated. We see 2 probes, then 4, then a ring of probes, all circling the blackness of the void. It's an optical illusion caused by the warping of space. But for the engineers at the Goddard Space Flight Center, it's a navigation nightmare. Which one is the real probe? And more importantly, which one is still sending us data? The challenge has now reached the level of a global crisis. The displacement of the Oort cloud is creating a secondary wave of comets. Because the silhouette is plowing through the ice like a giant blade, it's sending thousands of ancient rocks screaming toward the inner solar system. We call this a comet shower, and according to the Vera Rubin Observatory's latest trajectory models, some of these rocks are now on an intercept course with Mars and Earth. The 3I Atlas was meant to be a scout, but the entity it found is currently knocking over the furniture in our backyard and throwing the pieces at us. At the Harvard-Smithsonian Center for Astrophysics, the debate has turned to the silence of the object. If it's scanning us, and if it's using our sun for power, why hasn't it tried to communicate in a way we can understand? The theory being floated is that we aren't the ones it's looking for. The 3I Atlas is just a curiosity, a bug on a windshield. The shadow is looking at something much further in. Its course corrections aren't just to intercept our probe. They are being calculated to align with the Earth's orbital plane. It is steering itself into the very heart of our territory. And it's doing so with a level of mathematical precision that makes our best supercomputers look like abacuses. The 3I Atlas is now starting to send back vibration data from its hull. The probe is literally humming. The frequency of the hum matches the heartbeat we detected in the Arecibo legacy data. This suggests that the shadow is using acoustic gravity waves to speak to the probe's physical structure. It's not using radio, it's using the metal of the probe itself as a speaker. We are currently trying to record this space song to see if there's a message hidden in the vibrations of the 3I Atlas's titanium frame. As the vibration data from the 3I Atlas intensifies, we've hit a moment that has effectively frozen every conversation at the NASA Jet Propulsion Laboratory. The void is no longer a static shape. We are witnessing what structural engineers call geometric unfolding. The smooth, light-consuming silhouette is beginning to deploy millions of independent leaf-like panels. This isn't just a surface, it's a dynamic array. Based on the mapping from the Vera Rubin Observatory, these panels are shifting to capture the extremely faint light of distant stars, effectively turning the entire moon-sized entity into a giant panoramic eye. This unfolding has caused a massive shift in the object's gravitational footprint. As the panels extend, the 3I Atlas's sensors are picking up a sudden drop in localized density. It's as if the object is becoming hollower to increase its surface area. The team at the Harvard-Smithsonian Center for Astrophysics believes this is a thermal management maneuver. By unfolding, the object can radiate the massive amounts of energy it has been absorbing from our sun back into deep space, preventing its internal systems from melting. This is a level of heat sink engineering that makes our most advanced satellites look like primitive tools. But the real problem is what this unfolding is doing to the surrounding Oort cloud. The mechanical movement of these panels is creating pressure waves in the thin gas of the outer solar system. We're seeing a shimmer effect, a massive glowing aurora that stretches for millions of miles behind the silhouette. According to records from the European Southern Observatory, this aurora is composed of ionized neon and argon, elements that are usually inert but are now glowing because of the sheer electromagnetic noise coming from the shadow. It's like the entity is creating its own atmosphere in the middle of a vacuum. Back at the Keck Observatory in Hawaii, the gravitational lensing has taken a bizarre turn. Because the object is now unfolding, the light of the stars behind it is being sliced. Instead of a smooth ring of distorted light, we're seeing a strobe effect. As the panels move, the stars behind them blink in a sequence that the computers at Stanford are trying to decode. Dr. Martinez and her team are wondering if this is a secondary form of communication, a visual telegraph meant for something or someone even further away than Earth. Using the Ronald Bracewell radio astronomy concepts, they've noted that the timing of these blinks matches the prime number sequence, a universal sign of intelligent intent. Meanwhile, the 3I, Atlas, is being pulled into the interstitial spaces between these unfolding panels. The probe is no longer flying alongside the shadow, it is being inhaled by it. We've lost all visual data from the probe's external cameras because the light-consuming property of the panels is so absolute. However, the inertial measurement units are reporting that the probe is being moved with extreme gentleness. There are no sudden jerks or collisions. It's as if the 3I Atlas has been caught in a giant velvet-lined glove. The global gravity sensors are now reporting a harmonic resonance. The spikes aren't just random anymore. They've settled into a low, steady hum that matches the 7.83 Hz frequency of the Earth's own ionosphere, known as the Schumann resonance. This is a terrifying coincidence. It suggests that the shadow is now frequency matching with our planet. It's not just pulling on us with gravity, it's trying to sync up with our world's natural electrical pulse. The scientists at the Goddard Space Flight Center are calling this a gravitational handshake, and it has forced a total reevaluation of the 3I Atlas mission's safety protocols. The non-ballistic maneuvers have also reached a new level of complexity. The shadow has completely stopped its forward momentum toward the inner solar system and is now anchored at the very edge of the heliosphere, the boundary where the sun's solar wind meets the interstellar medium. By sitting on this boundary, the object is essentially plugging in to the entire electrical circuit of the solar system. It's using the termination shock of the solar wind as a power source, turning the edge of our home into a giant battery. This is the challenge we're facing. We have a moon-sized, light-consuming entity that has captured our most advanced probe, is currently unfolding into a giant eye, and is syncing its pulse with the Earth. And yet, there's still no heat, no radio message we can understand, and no visible pilot. We are staring at a silhouette that has become a system. The 3I, Atlas's last clear telemetry, shows that the interior of the void is filled with a fluid-like dark matter that is currently flowing around the probe's hull, absorbing its heat and its signals. We are being muted by a giant that is just beginning to speak. The 3I Atlas probe has just crossed the event horizon of the silhouette's influence. And what we're seeing on the monitors at the Jet Propulsion Laboratory is a total collapse of known physics. The climax isn't a collision, it's a revelation. As the probe is pulled into the center of the void, the light-consuming panels have formed a perfect sphere around it, cutting off the rest of the universe. For a split second, the 3I, Atlas's sensors, recorded a density spike so high that it literally warped the silicon in the onboard processors. We aren't looking at a machine anymore. We are looking at a singular point, a man-made object sitting in a pocket of space where gravity is being manufactured like a product. The final data packet from the 3I, Atlas, recovered through a heroic effort by the Deep Space Network using gravitational wave reconstruction, shows the core of the entity. It's not a cockpit or an engine. It's a vast liquid mirror surface that reflects the 3I, Atlas back at itself, but with 1 billion years of simulated evolution. This is the climax of the Bracewell concept, a mirror in the dark that shows us not who we are, but what we could become. The shadow isn't a threat to the 3I, Atlas. It is a gardener, and has just decided that our solar system is finally in season. The gravity sensors on Earth have now leveled off into a steady, rhythmic pulse that matches a human heartbeat at rest. In the end, the 3I, Atlas, didn't go dark because of a malfunction. It went dark because it was translated. The last telemetry indicates that the probe's atoms were restructured into the same light-consuming material as the shadow itself. We haven't lost a probe. We've contributed to a colossal interstellar intelligence that has been waiting in the Oort Cloud since before the first tree grew on Earth. The silhouette is now moving again, not toward us, but upward, perpendicular to the orbital plane of the planets exiting our jurisdiction with the same non-ballistic grace it used to arrive. It has what it came for: a sample of our best tech, a handshake from a young civilization, and a map of our potential. As the colossal shadow fades back into the frozen depths, it leaves behind a cleared path in the Oort Cloud that will remain a monument in our sky for 1,000 years. We are left with more questions than answers, but one thing is certain: the laws of physics aren't as rigid as we thought, and we are definitely not alone in the quiet corners of the dark. The 3I Atlas mission is over, but the era of authorized physics has just begun. We are now a planet that knows there is a bigger eye watching from the rim, and it just finished its first scan. Subscribe to the channel to see what the James Webb picks up in the shadow's wake. Watch the next video on your screen to learn about the hidden structures found in the Kuiper Belt. Don't miss our deep dive into the 3I, Atlas's final recovered image.